We now have the low points plotted, and we can move on to placing our first inlet. Starting on page 1-14 in our training guide, we're going to place an inlet CB-1 and familiarize ourselves with the node configurations dialog. So in our site plan DGN file, we're going to place node CB1 in the parking lot. So I'll zoom into that area. I can access the node configuration dialog by going Drainage, Component, Node, and Add. The dialog will pop up to add a new node. The node ID will appear, and it will be defaulted to my naming conventions set up in the project preferences. I can add a description, that's optional. I'll just click OK. I'm now at the node configuration dialog, where I'm going to set up several details on the left hand side of the dialog about this particular node. First is the properties options, the node type that I'd like to place from the available types that we have. In this case, a curb inlet. The profile type, and in my case SAG, and then it shows me the library items that are curb SAG inlets. I choose the appropriate one that I want to use, and I can see a preview of what it would look like, the cell itself will look like. On grade inlets, the dialog's a little bit different. You have an option to choose a bypass node to assign bypass flow, and then the maximum bypass flow that you would want to assign. The next option that we can take a look at is the location. Where do we want to place the node? Several options on this dialog for placement. If I had an alignment and a profile, I could place the inlet or structure at a specific station and offset related to that alignment or chain. Tangent to it. In our case, I want to say I don't have an alignment or a chain and profile, so I want to go tangent on element. I want to say tangent to the edge of pavement. Now when you choose tangent on element or tangent to element, either one, you have a selection to select the element you want to be tangent to or tangent on. So I'm going to click the Select MS Alignment Element icon and select the edge of pavement and accept it, or left click. Next, I'll grab the Station DP icon on the dialog, pull my mouse over into the view, and I can see the structure, and it's locked onto the alignment or element that I selected. Here I want to change the angle to 180 because I need the box to be on the pavement side. And simply just data point when you get it to the location you desire. That establishes its XY location. It temporarily plots it and it labels it CB-1, and these are based on my preferences. At any point I can click apply and it will permanently be placed in the file and permanently added to the drainage file. I'll move to the spread section, and this particular portion of the dialog and the options is where I set up the slope coming in from the left and right, because I'm in a sag situation, and the percent of discharge that's coming from the left and the right. In my case, I'm going to say 2% slope from the left, I've got a 0.5% slope from the right, and 10% of my discharge will be coming in from the left hand side and 90% from the right hand side. And these are arbitrary and obviously have to be keyed in, so you as the designer can determine what the percentage of discharge is left and right. I'm going to look at this as if I'm standing in front of the inlet looking and facing towards it. Next is the spread source. Here we can reference a surface, select a library item, so it would use a standard spread source, shapes, if we had some shapes calculated for super elevation, or user supplied, where I simply just come in, key in the width of the spread section, 63 feet, the percent of slope, 2%, that's the cross slope of the parking lot, as I'm standing at the structure looking back away from it, and then a spread source, or a Manning's number for the roughness, 0.012, and I add that using the icons on the right hand side of this list. I add it to the list. In this portion of the parking lot, I simply have a raised curb, so there is no gutter, so it's straight 63 feet away to the other edge of the parking lot, or parking bay. The other information on the dialog is maximum ponded depth and width. These are values in feet that I want to be alerted to if in fact the spread calculations and the calculated widths and depths exceed these values. I want to be notified in a report, so I put those in at 0.7 and 15. Next up is my elevations. Establishing the top elevation of my structure, I want to read a surface. In our case, I'm going to read the site model tower. The elevation source, I'm going to reference the model, or I could key it in. Since I do have a surface or a site model, I'm going to go ahead and read it, reference the model. I could still have a surface and not actually use it, and that would be user supplied. I'm going to reference the model, and so it calculates based on the location that I chose. It reads an elevation. The node elevation, I'm going to set it same as source, because I'm actually reading the elevation right at the edge of pavement. But if for some reason I had set this particular cell up to read the elevation on the back side, maybe it would be picking up the back curb elevation. That would be a little bit higher than where the actual water will enter the structure. And in that situation, I might set a constant offset of -0.5. So I'll set this back the same as source, because my elevation is for the water entering the structure is the same as the elevation it calculated. Now for the pipes that will be coming into the structure and exiting the structure. How do I want to align those pipes? In my case, if I can set it to match soffit, which would align the tops of the pipes in and out. I can match the bottom, or inverts, the water surface. I can allow for a drop through the structure, so if one pipe needed to drop, it would. Otherwise, that would match the soffits, if possible. Or a minimum fixed drop, so I could set a certain value through every structure that it forces a drop, and match center line. I'm going to set it to match soffit in this case, and align the tops of the pipes in and out. minimum depth of 3 feet to the top of the pipe, and I'll say a maximum of 10 feet to the bottom. That will give it a sufficient amount of room to design the system. Now each node will have this information, and when we design the system we'll take into account the min-max depths along with some other design criteria. Again, from your project preferences, you've had some capacity criteria to look at, minimizing cover and so forth. So that will give us enough information to kind of form a design envelope to work with. We could also add a sump depth if we needed at each structure as well, and that would be below the invert of the pipe. Otherwise, the invert of the pipe will be the bottom of the structure. Junction losses, I'm going to go ahead and use my project preferences or set up to compute junction losses and the equations therein. I could set it to none if I want to disable it for this particular structure but calculate it for others. Discharge options, I'm going to compute the discharge from a drainage area that I'll create later, but I also could have a supplied discharge and key that in. Or maybe I want to disable the inlet calculations altogether and key in a capacity. And finally, I have an option to link another drainage area. As I stated earlier, one inlet will be assigned to a drainage area and they'll be named the same. So I need to create a drainage area CB-1. So we know that area CB-1 and that runoff goes to inlet CB-1. But if I had another area, a second area that I wanted to bring to the structure as well and make sure that it worked, then I could link it to another area. There's no need to use this option if I don't have that second area. We already will know that area CB-1 will drain to inlet CB-1. The computations, there'll be none at this point, and that's because I don't have a drainage area. So I'll go ahead and click apply, and that will save CB-1 to my drainage project.